Hello all, I am SINDHUC. In this video lecture, I will be discussing about the structures concept in C. So these are the contents that we'll be covering in this lecture. First, the introduction, where we'll be discussing about what is a variable, what is an array variable, and what is a structure variable. Then what are structure data types, how to define a structure, how to declare structure variables, how to access structure members, structure initialization, then copying and comparing structure variables, operations on individual members, arrays of structures, how to handle arrays within structures, structures within structures, how to work with structures and functions together, size of structures, and what were the references that I've referred. Introduction. So a variable is a data name under which you can store a data value of any type. Basically, a simple variable means it can store primitive data type value. So here in this example, value is a variable of the type int, and here it is storing a value 10. The second one is an array variable. An array variable stores n number of data of the same type in contiguous memory location. Array is a derived data type. Here the word values is a variable of the type int. Inside square brackets we have 5, which means values can store 5 integer data values. Here the values are 1, 2, 3, 4 and 5. Similarly, a structure variable can hold data of different types together. A structure is a constructed data type. Here in this example, we have 4 structured variables: Sita, Ram, Krishna and Radha. So the type of values that all the 4 of them can store is a character array of the size 20, an integer value and a long int value. Structured data types. General examples of structured data types are arrays and structures. They are called structured data types because they can represent data values that have a structure. These structured data types provide an organizational scheme which demonstrates relationships among individual elements and also help in efficient data manipulation. Another dimension of it is called data structures. Apart from these, C also supports linked lists, stacks, queues, trees, and few more. Defining a structure. So before we use structures, it must be defined to specify their format. Unlike arrays, structure variables can be declared later. So here in this example, we don't have the structure variables yet. We are only defining it. So please go through the snippet. Here you have the keyword struct, then you have the tag name. It's called a structure tag. Here the structure tag is student. Inside curly braces, you have 3 attributes of that tag, which is student. So here name, age and register number, they are the attributes of student. Now these attributes here in structure, they are called structure elements or structure members. So this is a template. You can understand how the values are stored. So until you create a variable, there is no memory allocation or memory allocated for variables. It's just a template where there is no memory allocation. So name, which is a character array, say of size 20, age is of the type int, and register number is of the type long int. So if variable is created, memory allocation will be placed. Until then, it is a simple template. So this is the syntax of how a structure is to be defined. So we have already seen the example. So this is the syntax. So struct is the keyword. Then you have the tag name. Inside curly braces, you can define as many members along with your data types. Close the curly brace with a semicolon. So this is how you define a structure. So as explained earlier, the entire structure definition can be considered a single statement. That is why we are terminating it with a semicolon. Each member is declared independently. You have a different name, you have a different type, and you're terminating it with a semicolon at each line. And there is a tag name using which you will be declaring the structure variables later. Next comes declaring structure variables. So we have already defined a structure. Now you're going to declare structure variables. So there is a difference defining and declaring. Usually, declaring structure variables is done after defining the structure. So declaring structure includes, first you should have the keyword struct, then you should have the tag name, then the list of variables separated by comma, and finally you terminate it with a semicolon. We have already seen it, the same line in the previous slides. So the example is again given here. So use the word struct, then give the tag name, which is student. Then you can mention as many students you have in the class, which are the independent variables. So here it is Sita, Ram, Krishna and Radha. So these are the various structure variables of the type struct student. Here you have separately made the structure definition and structure declaration. Here both of them are made together. So you have the struct keyword, then you have given the tag name, then you have all the attributes specified. At the end of it, you have the variable names, terminating it with a semicolon. This is also feasible. This is also valid. There is one more thing, which is use of tag name is optional when you are combining the definition and declaration together. So in the second snippet, you can see that the tag name is missing. Now, after you have defined it and after you have declared the structure variables, how to access the structure members. So now I hope you understand that structure members are different and structure variables are different. Only with structure members, there is no memory. You have to create structure variables, then access it using the structure members. So it is necessary to link the structure members to the structure variables to make them meaningful. For example, age register number simply does not make sense, but register number of Ram and age of Krishna makes sense. So in order to connect this structure variable and structure members, we use dot operator or the period operator. So here is an example. Directly we can use the structure variable, use the dot operator, then the structure member. So here's Ram is the structure variable. Then you have the dot operator, age is the structure member. Then you are assigning the value of 50 to that member. Now similarly, Krishna is the structure variable, register number is the structure member, and you are assigning 1 to that. There is one more, this is a simple assignment. You can also use scanf statements to accept values at runtime. So just like you use a variable, you can use the same variable structure variable dot structure member. Structure initialization. Structure variables can be initialized at compile time. So here in this example, inside the main function, we are creating the structure definition along with the structure declaration. So here the variable Ram is assigned two values 16 and 98.5. So this automatically assigns ram.age is equal to 16 and ram.c programming marks as 98.5. There is a one-to-one correspondence between the members and their initializing values, which is first value is of the first members. Here the first member is age. First value is 16. So 16 corresponds to age and 98.5 corresponds to the second member, which is C program marks. So here is one variation. Here the definition is given separately, then you are declaring it separately. So when we are declaring it, there you are initializing. So in the declaration of the variable Ram, you are assigning values 16 and 98.5. Then when you are declaring Krishna variable, you are assigning 20 and 99.5 marks. This is one way of initialization. This is the second method where one variable is created along with the definition. Ram is equal to 16 and 98.5. Inside main, you are creating the variable Krishna and you are assigning the values 20 and 99.5. And there are two more points that is to be included, which is initialization of individual structure members within the template is not allowed, which means inside the definition, I cannot simply say int age is equal to 5, which actually means age is equal to 5. We do not know it's of Ram or Krishna or any number of variable which is coming after it. Then the second one is initialization must be done only in the declaration of actual variables. Wherever you are creating the variable, say Ram or Krishna, along with it you will have to give in the initialization values. So these are the elements required for compile time initialization. So above I have given all the 6 components, below I have given an example. So first the keyword struct, then you should have a tag name. So in the example the tag name is student. Then inside curly braces you have two members, which is age and C program marks. Then you have the variable Ram, and then you are giving the two values corresponding to those structure members. So age is 16 and C program marks. The last component is the terminating semicolon. So this is a simple example. These are the 6 essential components required for compile time initialization. Rules for initializing structures at compile time. So the first two rules we have already seen with an example. So the first one is initializing individual members inside the structure templates cannot be done. As I told, age is equal to 15 or marks is equal to 20. We cannot initialize it inside the template. Only initialization is possible with respect to the structure variables, not with respect to structure members alone. The second one is the order of values enclosed in braces must match the order of members in the structure definition. So if the structure members are age and then you have the marks, during initialization it should match, which is you give 20 and 30. 20 first matches with the age, 30 matches with the marks. So it should match in order. The third one is partial initialization is permitted, where the first few members can be initialized and the remaining can be left blank. So if you have 5 attributes, you can choose to initialize the first 3 members or first 4 members or first 2 members and leave the remaining blank. These uninitialized members will only be allowed at the end of the list, and these uninitialized members will be assigned with default values. So default values are 0 for integer and floating point numbers and null character for string and characters. Copying and comparing structure variables. Two variables of the same structure type can be copied the same way as ordinary variables. So here in the example that we are going through, Ram and Krishna are two structure variables of the same type. So copying Krishna's data into Ram or Ram's data into Krishna, whichever is having data can be put on the right side of the assignment operator. And the values of the right hand side variable will be copied to the left hand side variable. So this is possible copying. The second one is C does not permit any logical or relational operations on structure variables, which is you cannot compare Ram and Krishna together, which is Ram is equal to Krishna or not. All that cannot be checked. But you can compare it individually using structure members, which is ram.age is equal to krishna.age. So that kind of comparison is possible, but directly with structure members alone, this kind of logical and relational operations cannot be performed in C. Operations on individual structure members. So individual structure members, we already saw that we can use dot operator or the period operator to access them. So which is structure variable dot structure member. So that can be treated like any other variable name. So manipulations using expressions and operators are possible. So here in this example, if ram.age is equal to krishna.age, this can be checked. Krishna's age and Ram's age, are they equal? We can check it and perform some operations like Ram's program marks can be increased by 10. Second thing is increment decrement operators can be applied to numeric type of members. So Ram's age, Krishna's age, so you can increment, decrement, all that. Then precedence of member operator is higher than all arithmetic and relational operators, hence parenthesis is not required. These are the basics that you should know on operating on individual members. So next topic is arrays of structures. So in the previous examples, we have seen that structure variables were Ram, Sita, Krishna, Radha, all that. So instead of naming them, if you want to just give numbers like student 1, student 2, student 3, here is an example where we are using arrays to have count of the students. So here you have the tag name marks. The structure members are subject 1, subject 2 and subject 3. Inside main function, we are creating the structure variables. So we have created 3 structure variables. So they are student 1, student 2 and student 3. So because we are using an array, it is going to be student 0, student 1 and student 2. So ultimately we have 3 students, and we have also made the initialization. Student 0 takes 3 values for subject 1, subject 2, subject 3, which is 81, 91 and 78. Student 1 takes 3 values for subjects, which is 75, 83 and 96. Student 2 takes 3 values for his 3 subjects, which is 76, 97 and 89. So this is one way of using arrays in order to create structure variables. The continuation of the previous slide. To the right hand side of the slide, you can see the memory depiction of how the values are stored in the memory. Student 0's first subject mark is 81, student 0's subject 2 mark is 91 and so on. If not for the previous slide's way of initialization, you will have to assign it like this: student 0 dot subject 1 is equal to 81 and so on. This is individual assignment. In the previous slide, we saw how to assign it in one go. Arrays within structures. So here in this example, you have a structure. The tag name is marks, and you are creating 3 students 0, 1, 2. You have 2 structure members, register number and subject. Now this subject is again split into 3. Here you have an array inside this structure. So this subject is again subject 0, 1, 2. So you have 3 more structure members inside it. So totally this tag marks has 4 structure members inside it: register number, subject 0, subject 1 and subject 2. So C permits the use of arrays as structure members. We have already seen it in the previous examples where you have created a structure member name of the type character array of size 20. So single or multi-dimensional arrays of type int, float, char, all that is allowed in C. So in this example, you can consider student 0 dot subject 2, which is first student's third subject mark is so and so. You can assign some value to it or you can print it out. Structures within structures is basically nesting of structures. So here you can see one structure is placed inside another structure. The outer structure is the salary structure, the inner structure is allowance structure. This allowance structure has three members, DA, HRA and CTID, and it has two variables, employee allowance and employee arrears. And the outer structure, you can see it has two character arrays, name and department. And the third one is the structure data type. The outer structure has 100 variables, employee 0 to employee 99. So the access can be using two dot operators. Structures and functions. There are three ways by which values of a structure can be transferred from one function to another. The first method is passing each member of the structure as an actual argument of the function call. So this becomes unmanageable when the structure size is very large. The second method is passing a copy of the entire structure to the called function. The third method is using pointers, pass the structure as an argument where the address location of the structure is passed to the called function. Here I have discussed the general format or template or the syntax of the call and called function. The first one is the function call. You have the function name and the structured variable's name inside the parenthesis. The structure of the called function is the function calls function definition. So you have the data type, you have the function name, inside the parenthesis you have the struct type and the struct name, and then you have the body of the function. Size of structures. You have the size of operator using which you can identify the size of the structure. So size of is a unary operator. So using size of inside the parenthesis using struct x, you can get the size of that particular structure. So size of struct x evaluates the number of bytes required to hold all the members of the structure x. So if y is a simple structure variable of the type struct x, then you can use size of y to get the size of that particular structure y. So far I've discussed the basics of the concepts of structures in C. The main reference is Programming in ANSI C, 3rd edition by Balagurusamy, and I've also referred few syntaxes and examples from Dennis and Ritchie, the C Programming Language 2nd edition book. Thank you.